All right, how am I going to start this warm-up? Yeah, you have to divide everything by -1 because we want y by itself. So that's going to change the way our symbol is facing. Great. And now this is the equation we're going to graph. So the y-intercept here is at -3. That's going to be my starting point. The slope is -2, which means I go down 2, right 1. We're kind of off the graph, so you could also go up 2, left 1 if you want another point. Is this going to be a solid line or a dotted line? Dotted. Why? Yeah, it's not or equal to. So just kind of draw an open line. Again, we're looking at this symbol to determine that. Now, where am I going to shade? Looking at this symbol, where would the y's be less than this line? Down. Good. Another way to do it, if you don't like that method, is to use a test point. 0, 0 is always the easiest test point. If you put 0 less than -3, that is not true, so you would not shade in the region that had your test point in it. You shade in the other region. So either way, we get that we're shading below the line. The line is dotted, and there is its location. What are your questions? All right, today we're doing section 2.7. It's all about piecewise functions. You can see our goals are listed below. All right, we will start with the definition of a piecewise function. A piecewise function is a function represented by a combination of equations. So here are a couple examples below. Like I was saying, they're in pieces. That's why they're called piecewise functions. So it'll give you an equation, more than one. So 2, maybe 3, maybe 4, maybe 5. And it'll tell you exactly how the graph is broken up. So it'll tell you something like when x is less than 1, this is the graph. When x is greater than or equal to 1, this is the graph. So it's kind of like graphing 2 lines at once and then just figuring out which part to erase. Here's one that's a little more complicated than we would do, but you can see there's 3 different equations. So one equation looks like it's less than or equal to -1. Then this other equation looks like it's between -1 and 2, and then when x is greater than 2, it's that equation. So kind of fun graphs, pretty interesting. Any questions on those? Yeah. All right, here's the information we're going to use for our first couple examples. So I want you guys to write these down. As you're writing them down, I'll describe how these are always written. So you might recognize this function notation, f of x and g of x. We've already talked about that type of notation. These are 2 different functions. You can tell they're piecewise functions because they have more than one equation and they have parameters afterwards. So if you are given an x value that's greater than 1, you use this equation. If you're given an x value less than or equal to 1, you're going to use this equation. And that's if you're talking about f of x. If you're talking about g of x, this says x less than 5. So if x is less than 5, you use this equation. If x is greater than or equal to 5, you use this equation. So we're just going to practice evaluating these. The first thing you want to do is figure out which part of your graph it's going to fall into, and then actually evaluate it. Any questions on the setup? Like I said, this is kind of a new concept, so it might take some getting used to. Here's the first one. G of 5. So does g of 5 fall into x less than 5 or x greater than or equal to 5?
Greater than equal to.
Good. So I know I'm in the g function. I know I'm at this equation. So now I'm just going to plug 5 in to -2x. What does that give us? -10. So not too bad. Once you figure out where you're going with this, the actual math isn't the hard part. The hard part's figuring out which one you're plugging into. Here's example 2. We want f of 0. So I know I'm looking at my f function. You have to decide, is x greater than 1, x less than or equal to 1? Which one?
-2. That's the answer.
Oh, you're giving me right the answer. Yep, we're going to use this equation. Good. We're going to plug 0 in, and you are correct. It is negative 2. Next one we're going to look at is f of 3. So you have to decide, is that greater than 1? Is it less than or equal to 1? Greater than 1. So I'm going to use this equation. Plug in the 3. I already heard the answer in the back. It is indeed 4. And the last one, I want g of negative 2. So is that less than 5 or greater than or equal to 5? Less than 5. So I'm going to use this equation. I'm going to plug in negative 2. I'm going to evaluate it. You get negative 6 plus 2, which of course is negative 4. What are your questions on this? So I hinted at this earlier. When you are graphing a piecewise function, you are essentially graphing 2 or more functions and then just figuring out what part needs to be erased. So I want to start by graphing the function x plus 2. You can think of it as y equals x plus 2. So where would I start? If I was going to graph this function, don't worry about this part yet. If I was just going to graph this function, where would I start? The 2, right? Then what? What's the slope? On this one, it's positive 1, right? So up 1 over 1, up 1 over 1, and then you draw in the line. Now, if you're doing this on your own, draw it very light. We're going to go back and erase some stuff. Because we don't actually want that whole line. We only want that line to apply if x is greater than 1. So where does x become greater than 1? Right here, right? This is x equals 1. So we only want the portion of the graph that applies to x being greater than 1. So we are going to put an open circle, because look, x equals 1 is not included. That's actually included in the other function. On this one, we just want it to start at x greater than 1, but not or equal to. So we put a circle there to show that that point actually does not exist, and then we just leave the rest of the function. Kind of complicated, but hopefully not too bad. What?
There you go, back to repeat.
Repeat the process?
Yeah.
Yes, here we go. All right, so I am going to graph this function right here. Y equals x plus 2 is what I'm graphing. So I start at the 2, that's my b, my y-intercept. I use the slope of 1 to go up 1 over 1, up 1 over 1, so I have these 3 points. With me? Draw the line. Draw it super light, because you're going to go back and erase some of this. Once you get good at this, you won't have to go back and erase. You can probably just do it all at once. But this is this function without these parameters. However, I need to consider these parameters. This is only the function I'm using when x is greater than 1. So, x is greater than 1 past this point on the x-axis, right? Here are values like 2, 3, 4, 5. That's the time when we would use this function. Does it include 1? This one? This one includes 1. So here we're going to use a solid circle. Here I need to use an open circle, though, to show that that is not actually a point on my line. So I'm going to use an open circle there. And I'm going to erase everything to the left, because that is not included in this function. It's going to be included down here. Yes?
I just wanted to know why it changed from negative x minus 2 to negative x plus 2. On the other page, it was negative x minus 2. Now it's negative x.
Oh, f of x is always different. So this isn't related to the previous f of x we looked at. Oh, good question. Yeah, this is just a new function. It's not the same function from the last page.
So which one are we going to know which one to use?
Whichever one's on the current page or the current problem you're looking at. You don't have to memorize what f of x and g of x are.
Oh.
I'll give them to you every time. All right, let's finish this problem. We still have the other part of the function to graph. So if I was going to graph y equals negative x plus 2, I would start at 2, but now I'm going down 1, right 1, down 1, right 1. So very lightly I'm going to consider that line. Now, once you consider where one of them stops, that's usually where the next one starts. So the first line that you see in green, that was x greater than 1. This one we want x less than or equal to 1. So I still want to consider this point, so this is going to be a solid circle right here. And then the less than is all the points to the left. So I only want to consider the graph to the left. All right, I'm going to give you guys a couple minutes to look at this. I see some bewildered faces. Just remember, depending on this information, where that line goes, okay? So graph the whole line and then decide where you're actually talking about. Graph this entire line, figure out where you're actually talking about, and you should have something like this. It shouldn't have overlaps, like if one of the lines goes all the way over here, the other line shouldn't start until over here, okay? Kind of tricky. What are your questions, though? So for example 6, I'm going to start it just like I did the last one. I am just going to graph this first function. I'm just going to ignore this for now. So I'm going to start at 4. I'm going to go up 1, right 2, and up 1, right 2 again. That's my first line. Any questions on how I got that green line? Now, where do I want that green line to stop? The 2, right? X equals 2 is going to be my turning point. Is the x equals 2 included in this one, or do I need an open circle at it? Open circle, because it's not or equal to. So that's the first thing you decide. I'm going to have an open circle here. And then I'm only going to include either to the left or to the right. Which one gets included here? It's less than. So I want to keep the part to the left. That's why I said draw very lightly. And as you get good at these, you can kind of do it all at once. But as you're first learning, you're probably going to have to go back and erase some stuff. So if you're using a pen, probably not the best writing tool at the moment. All right, let's graph the next one. So where does the second function that we're looking at, where does this one start? The 9, good. Slope is negative 2, so down 2, right 1. Down 2, right 1. Draw the line. Now, this one's a little easier, I think, once you get the first one done. The second one just kind of flows a little more naturally. Because since this one stopped at the 2, the next one has to start at the 2, and it's going to go the other way. So now we're looking at the greater than portion. Do I have an open circle or a closed circle, though? Closed for this one. And then it goes down. Great. And again, that's the region we're using because x greater than or equal to 2, so we want to start at 2 and we want to go to the greater than, which is to the right. What are your questions on this? So this is called a step function because when you graph them, it looks like steps. And it might be helpful as we're graphing these to remember that f of x is the same thing as y. So this is like y equals 1, y equals 3, y equals 4, y equals 6. Those are all horizontal lines. So we're going to have a bunch of little chunks of horizontal lines. That's why they call it a step function. It looks like a step. All right, so let's focus on the y would equal 1 line. We want that to start at the 0 and go to the 1. So 0 to 1 would be in this region right here. Correct? Including 0 or not including 0? We're right here. Including 0 or not including 0? Not including 0. Including 1 or not including 1? Including 1. So I need a closed circle at x equals 1. I need an open circle at x equals 0, and I just want to focus on the line y equals 1. So it would look like this.
Can you re-explain that? 'Cause I was wrong.
Yes, definitely. Okay, we are just going to graph this part of this line, y equals 1. Y equals 1 is the horizontal line through the y-axis at the point 1, right? So we would just be focusing on this line. However, we want that line to start at 0 and end at 1, including the 1, not including the 0. So x equals 0 is right here. We don't want to include it, so I use an open circle. We do want to include the 1, so I use a closed circle. And again, I'm just focusing on the line y equals 1. The next one I'm going to focus on is y equals 3. So now I'm up at 3. I would just be focusing on this line right here. I want it to start at 1, end at 2, not including the 1, but including the 2. So that's where I want it to end. That's where I want it to start. So for our next step, we are going to be looking at y equals 4. That will be up here. I want it to start at 2 on my x and go to 3 for my x. So I am going to use this little piece right here, not including the 2, but including the 3. So it's going to be along that. Open circle, though, at the 2. Closed circle at the 3. The next one I'm looking at is when y equals 6. So that would be up here. I want it to start at 3 for my x and go to 4 for my x, not including the 3, but including the 4. So let me get those on there, and then we'll stop for questions. So I'm going to think of y equals -1. That would be a line right here. Next, I'm going to think of y equals -2. Well, that would be a line right here. Y equals -3. And y equals -4. So I'm basically going to have 4 lines right in a row. But I need to figure out where those lines would fall. So for the -1 line, I want it to start at the x value of -2. And I want it to go to the x value of -1.
-1, that's so positive.
Oh, sorry. +1. You're right. I need to move this projector. It cuts those off. But yeah, I should have been able to see the negative sign. Good. So starting at -2, going all the way to 1, not including the 1, but including the -2. Any questions on the first part? The next line I'm looking at would be y equals -2. Again, we said it would be along this line. We want it to start at 1 for our x values. We want it to end at 3 for our x values, including the 1, not including the 3. Next, we're going to think of y equals -3. That would be the horizontal line right along here. I want to start at the x value of 3, end at the x value of 6. So it's going to be closed on 3, but open on 6. And it's just a horizontal line between those two. Next one, the y equals -4. Starting at 6, going to 8, including the 6, not including the 8. What are the questions you have? Yes.
Are we ever gonna...
Here's your homework on Peicewise Functions. Again, they're only odds, so you can check them. I will definitely open the floor for questions at the beginning of class tomorrow. So try your best on these. I know it's a new concept. It's kind of tricky. See what you can do, and we will do as many as we need to on the board tomorrow.
I've been watching them.
Questions?